Hello, I'm Leonid Svyatsky,
And I'm Aaron Phillip.
and we're from Los Alamos, New Mexico in the US.
In our project, we attempted to use machine learning, which is a type of AI that can recognize complex mathematical relationships, in order to recognize different types of noise frequencies in data collected over time so that we could filter these different areas differently. We applied our method to the nanopore DNA sequencing problem.
Nanopore DNA sequencing is a type of DNA sequencing technique where you take a strand of DNA and you feed it through a pore. And as the DNA is traveling through the pore, you get a reading of a current. This method is really efficient, but the only problem is you get a variety of noise in the data that you collect.
That makes it really difficult for a computer to be able to classify exactly what the nucleotide sequence is. So we hope to apply our technique to improve that accuracy. So we computationally modeled the behavior of circuit filters, which are capable of reducing that type of noise, in Python and wrote our own code that could choose the correct parameters for filtration when given a noisy signal and the corresponding truth signal.
We verified this by using a Raspberry Pi to create a square wave. We filtered the square wave both computationally and physically, and comparing the results, we were able to verify that the optimizer as well as the code was working properly.
Then we used our optimizer code to build our own database by passing realistic nanopore data through our code, collecting the best parameters for filtration and storing it in the database. Then we trained machine learning models to be able to predict those parameters for filtration when given small segments of data. Currently, we achieve a variety of performances, and we hope to improve the efficacy of each of these by using a fast Fourier transform layer in our neural networks in order to have our models learn directly from frequency data rather than time series data.
We plan on comparing continuous filtration with segmented filtration by experimentally utilizing variable capacitors on data collected over time, such as seismic data.